Thank you for pointing out. Yes. So I hope my screen is now visible. So I'll just show you again. So this is the CSV file I'm talking about, and this CSV file is not mine. I have actually taken it from somewhere. And if you open it with text editor, you will be able to see what I was talking about. So these are actually values where a comma is indicates the next value in the row, and an enter indicates a new row. All right. So this is how a CSV file is stored in memory. Now I'll just go to Jupyter, and this is how we load CSV file in memory. So we'll say pd.read CSV and we'll give the file name. The file name is actually NYC. So New York underscore weather dot CSV. And if you load this, you will be able to see all the data plus it has been loaded in the memory and you can store it in a data frame. What is a data frame? What is a series? We'll see in just a little bit of time. So I'll just name it df is equals to pd.read CSV so as to assign this data frame to this uh, variable called df, and we will see what this df is. All right. Now suppose from this data, if you want to ask few questions like what is the mean temperature or maximum temperature in this time. So it is actually mmdd YYYY. So it is month, date, and year because it is of US data. So you see, you have 30 days data and you want to get the maximum. If you are not using data frames, you would have to, so loading of data, assigning one object to all the columns and then taking maximum requires a lot of um, looping and a lot of code. I'll show you one such code of doing the same thing, which we'll do using pandas. So first we are using pandas to do this. And why are we doing this? Because I want to show you how pandas makes our life easier. It is a very useful, very powerful built-in um, package in Python. So you see, we have loaded the whole data in just one line. So this is in the memory of Python, and you can use the data and interpret the data using pandas library. So this is one data, and what do you want? You want to first extract the temperature column. All right. So you just have to do, so we have assigned this data frame a name df. So you just have to write df and then box bracket and you have to write the name of the column. So it is temperature. I'm just copying because the name should be exactly the same. So I have the temperature column over here. This is not a data frame. That is a series, which is also an object of pandas. And we will talk about it in a little while. But you can use the functions which pandas provide. One such function is .max. And when you do this, you will get the maximum temperature throughout this 30 days. Similarly, if you want to get, so you see there are events. So what is this event? It will say if there is no event or if there is rain, is there is fog, snow, or just snow. All right. So you want to extract the days. You want to extract the days in which rain occurred. So how do we do that? We will talk about it, but I'll just show you that you can do that using just one line. All right. So you do like this. So it will say df and then say events, and you write events over here and you have to say equal to rain, RAIN, and it should be exactly the same. All right, it is RAIN, yes. And then if you do this, you will get false, false, true, true, true. So it is just a series. We will talk about what series is. But in the row where there is not rain, it will be false. And when there is rain, it will be true. And I'm doing something which is a little bit complex, but you see how easy it makes to extract the days on which rain occurred. I have to write df and then a box bracket and I have to write this name. So it is est. When I write est and I run this, sorry, this should be passed like this. And then you will be able to extract the days on which rain occurred. All right. And it is, you see, these are very complex operations. If you don't have the knowledge of data frame and you want to do it using loading the CSV file, going through the data and then taking the maximum or extracting the days on which rain occurred, and I have copied the code of this from somewhere else. This is not my code, but you see, this is what you have to do if you don't want to use the data frame. All right. If you don't want to use data frame, this is what you have to do. And this is not my code, by the way. No? I have copied it from somewhere. So there is something called import CSV. It is a package, and this is a function which I have not I have defined. Someone else has defined. What this function does is it opens the file, and we have talked about open function, and it goes line by line, and it says the delimiter is comma. So you don't need to understand this code, but I'm saying how complex it is to do all the things. So you have to go row by row and then say wherever the row 0, assign it to date. So I'm making a dictionary. Row temperature, so the key is temperature, and give the value as row 1. And in this way, you have to make a dictionary to store the data from the memory. And Pandas made it so easy just by using this line. pd.read CSV, and you stored it in a data frame called df. But over here, you have to use open the file first, then read it line by line, and then you have to store it in a dictionary. And now if you want to take the maximum, you have to go row by row, and then you have to store the data and compare it with the maximum temperature such that you get the maximum temperature. And all this you did using just one line, df temperature dot maximum. Again, if you wanted to check if it is rain or not, you have to do these things. But here we did it in one line. All right. So this is not my code. I have taken from somewhere. This is important to tell you. All right. So this is what I wanted to show you, that pandas makes our life lot easier, lot easy when it comes to data. All right. Any questions? So in the last class, there was a question, why do we need array if we have list? So I answered it yesterday. Today I also am showing why data frames are important and how it is useful. You can do all the things data frame does using other objects like dictionaries, lists, etc. But this object data frame makes our life very easy when you are handling big data. Not big data, big data is a scientific term, large amount of data. All right. So any questions over here? We have not begun discussing about data frames. This is just to show you how powerful data frames are.
Okay, sir.
All right. So we'll start. First, we'll start. So I'll just write the heading called Introduction to Pandas. And we'll start with series. So what is the series? Series you will see now. Right. So you have to have pandas and NumPy. So I'll just write import. Okay, so I've imported NumPy and pandas. Now, what I will do is, you see, we have loaded a data frame. So let's see that, and then we'll understand what series are. You see, this data frame is actually in a tabular format. And each column, if you take one column and you extract that column, similar to what we did over here. So if I go a above and I say df temperature, so this is a series which has only one column. But what is this? Not this, the first column 0, 1, 2, 3, 4. These are indexes. So you see, you have index over here also 0, 1, 2, 3, and so on. So these are index. And it may not begin with 0. You can index it anything. You can just start with 100 and then the next can be 200. It's up to you. But the default index starts from 0 till however rows you have. So these are indexed. All right, so these are index, and these values are actually the data in that index. So this is what a series is. It is just one column of a data frame, and a data frame is actually collection of series. All right, so it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 series in this data frame, or 11 columns in this data frame. So a series is just a column of a data frame. So in this way, I'm defining it is not defined like that, but I'm defining it in this way because we have seen what data frame is. So from that, I am coming what series is, but actually it is not defined that way. All right. So I'll show you how to make a series. So you can say pd.Series. So S is capital, all right. Series, and you have to pass a list. Sorry, you have to pass a list. So first I'll define a list. It is better. So lst equal to, I'll say 1 comma 2 comma 3. So let me be 11 comma 22 comma 33 comma 44 comma 55, and I'll run this and I'll say pd.Series and I'll pass this list. So I'll say lst. So you see this is your series and the index is 0 1 2 3 4. You can change this index. How can you change this index? You can say, so you can either do comma and you write index and you give a list. So instead of that, I'm defining a list. I'm saying label is equals to A, B, C, and D. All right. So there are 5 numbers and E. And I'll say index is equals to label. And when you do that, so I'll just write it separately. All right. So it will be better for you to come back and see. Yes. So you see, I'm saying pd.Series lst and then index is equals to label. You can also write it as, so this lst should come first. If you are not writing it at first, you can say data is equals to lst. And now you can change the sequence. So if you don't want to write like this, so you can just say index is equals to label and data is equals to lst. This will also work. Why? Because you have specified index is label. So whatever the label is, this is the label and data is actually lst. So your index will become a b c d e and data will be 11 12 11 22 33 44 and 55. All right. But if you don't write index and data, then you have to specify the order. So you have to say pd.Series and the order should be data comma index. So it will be lst comma label. This order should maintain. So first the data comes, then index comes. All right. So this you have to remember. So you see index is A, B, C, D, E and data is 11, 22, 33, 44 and 55. So this is one way to define a series and the different variations of that way. Now you can have an array. You see this series is defined using a list. You can also have an array. So suppose you have an array np dot array and I'll just write this array 11, 22, 33, 44 and 55. So you see this is an array and you can just write arr equal to this and you can say pd instead of the list you can pass the array arr and you see we have the same series which we have earlier. So this can either be a list or an array. All right. If you don't pass the
Yes,
index, yes,
yeah, data type integer 64. What is mean, sir?
all the data which this series has is actually integers. If you say 11.1, then it becomes a float. Data type is float 64. So all the elements in this series are actually floating point numbers.
Okay, 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 yes, yes.
Okay, so we have seen one way, which is using list. The other way is using array. You can also use dictionaries. So remember, in a dictionary, you have key value pairs. So if you define key value pairs like this, A is actually 11.1, B is 22. So it is easier to see what is happening. Here we are defining data and index separately. But if you are using dictionaries, so the key will become the index and the value will become the value of the series. So I'll just define a dictionary quickly. I'll just say A colon 11.1 comma B colon 22. I'll have to have comma and just I'll say C colon 33 comma D colon 44, comma, and say E colon 55. So this is a dictionary which we have. DIC is the name of the dictionary. You can check. Yes, this is a dictionary. And you just have to say pd.series and just pass the dictionary. Here you don't have to define label and data separately, not label, sorry, index and data separately. You just pass the dictionary. Okay. SERIES. So you have the keys as labels, not labels, index, and the values as the value of the series. All right. So this is also a way to create a new series. All right. You can write the data in the pd.series itself. So suppose I'm saying ser1 is equals to pd.series, series series, and you can say data equal to, you can pass the data, so 10, 20, 30, and 40, and you can say label, not label, index is equals to, I'm just giving some names, so I'm saying India, USA, Japan, and then China. All right. And when you pd, and when you do this and you check what ser1 is, then you'll have this. All right. And one more thing, these labels can have different data types. So you can have USA not as USA just two, then this will also work. It doesn't matter that these values should be same or these values should be same, but generally it is not seen that these values are not same. I'll tell you why. So this will also work. You see over here, this is an integer, but this is a string, and this is a integer. So that is why it is saying data type is object. All right. So you may have different data types in the data or in index, but this is not generally seen. Why? Because suppose you have this data in your memory, or you have somewhere from some data you have. So in a column, generally the data type remains same. So suppose you have the temperature data. So it will not happen that one temperature is 38 and one temperature is ABC. It cannot happen, right? So generally it is seen that in a series, all the data types are same, but it is not compulsory. All right. So this is not generally seen. And I'll just say USA. All right. I'll define one more series. Series 2 is equals to pd.series. I'll say data equals to, and I'll give some data, say 20, 23, 40, 43. And I'll say index is equals to India. Then I'll say Russia. And over here I'll write France. And I'll say Japan. Correct. So this is one more series, which is this. Now you can perform operations in series. So suppose you want to add series 1 and series 2. So you have to see there are two common indexes. India is common and Japan is common. No other index is common. You see, USA is not there, China is not there. Over here, France is here, but France is not there. And Russia is here, Russia is not there. All right. So in that case, if you are performing some operations, you have to be sure if you want to do those operations or not, because index of the two series is not same. So suppose you are saying series 1 plus series 2. And if you do this, you will get, what are you getting? It is checking if the index is matching or not. So India is matching. So it is adding both of the data. So it is 10 and 23. You are getting 33. Similarly, China, not China, Japan and Japan is matching. So you are getting 73. Others you are not getting because in one series it is there, in other series it is not there. Therefore, it is saying NaN, which is not a number. All right. So you have to be sure if you want to perform the operation or not. And series is not super important. What is important object in this data frame is data frame. In Pandas is data frame. All right. So you use data frame, and whenever you extract some column, it is a series. That is why I was talking about series. All right. There are other operations in series you can do, but when you do some operations in data frame, you will actually come across the operations in series. Why? Because you will extract some data from a column and then perform some operations. Those are operations on series. All right, so I'll move to data frame now. Any questions in series?
No, sir. Okay.
All right. Now, before going to series, sorry, not series, data frames, I want to talk about one thing which we have not covered in random, which is seed. And you will use seed when you go to data analysis or maybe machine learning. Then this function, seed function, inside random module is used a lot. So what it is, we will see now. Before that, in yesterday's class, I talked about that random module is actually defined in NumPy. So you don't have to import random module. So if you say np dot random dot rand int and you say some range, say 20, so you don't have to import random module. But if you write random.random, then you have to import random module. All right. So random module is already defined inside the package NumPy. That is why you don't have to define this random module. Now there is a function called seed, np.random.seed, and I'll say, suppose I'll say 100. All right. And whenever you give a seed, so you see how uh, Python generates random numbers. What it does is it has a seed value. So what is seed value? It is initial point where the random. So you see, uh, actually what happens is Python takes the time you are running some random module, and from that time it has some algorithm to take random numbers. So the seed value is the time you have. So it starts with the time you executed random module, and there is some algorithm to go to the next number and to the next number and to the next number. All right, so that is what seed is. Seed is the initial value you want your algorithm to start from. If you fix your seed, if the seed is fixed, then every time you run that algorithm, you will get the same random numbers. Those are random numbers, but you will get same random numbers. I'll tell again, Python generates random numbers using some algorithm it has. And how does one random number you have generated differ from the other? It is because the starting state is different. And whenever you execute some random number function, it takes the starting state or seed as the time your computer is on. So it is some time it is taking, and then using that algorithm generates the random numbers. But if you fix the starting state or seed value, if you fix the seed value, it will give you random numbers. But every time the random numbers will be same. All right. So those numbers will be random. So suppose you want to, I'll just run this seed. I'll just run this seed and you just execute this. All right. np.random.rand it from 1 to 20. If I run this and maybe I want 10 numbers. All right. You see, I'm getting 9, 4, 8, 16, 17, 11, 3, 3, 3, 15. If you run this random.seed 100 and you run this, you will get the same value 9, 4, 8, 16, 17, 11, 3, 3, 3, 5, 15. You can check now and confirm maybe if you're getting the same number. Don't run it twice, run it once. So you run this once and run this once. You'll get the same but random numbers. These are random numbers between 1 and 20. Can you confirm? So is anybody running? All right. So you see why this seed is important. Suppose we are working in an organization and we want to run some code, but I want that everybody who is working in that project execute the same values and get results. So I want those values to be same in the all the persons who is in that project. And we want random number. That is why the seed is important. You will say that set the seed to this and then execute your code. So all the persons running the code will have the same random numbers. And then you can compare your data or sorry, results. All right. So you see, I'll run this code again. So I'll run this line again, seed 100, and I'll run this again. So I'll get same 9, 4, 8, 16. This number will be same. But if you run this value instead of running the seed again, then you will get different number. Why? Because you have run this random.rand int and the initial value or the starting state has been changed. If you run this, you will get different numbers. If you run this, you will get different numbers. All right. But the starting state, when you run seed, is fixed. Now, if you I have run seed and now I'm running this, I'll again get 9, 4, 8, 16, 17, 11, 3, 3, 3, 15. All right. So when you fix the starting state, it goes on and you have same data. So this seed is important. Is this all right? Okay. So now we'll see uh, how we define data frames. All right. So we'll say np.random dot rand n maybe 5 comma 4. So I'm asking Python or NumPy package to give me random numbers in standard normal distribution, and the numbers are so the matrix is 5 comma 4, and when you do this it is 5 rows and 4 columns, and I'm storing it in some array name a. All right, so this is the name of the array. Now I'm saying pd.DataFrame, and I'll say the name of the array I want to make it into data frame. So it is A. All right. And when you do that, okay, okay. You see F should be capital and D should be capital in data frame. So this is the data frame. So we made a data frame using a array. Now you see, when we were talking about series, you had only one row names or indexes. Over here, we have indexes in the rows and you have column names as well. And the default value of these are 0 to how many columns and rows you have. You can change these by defining the name of the index and columns. So you can say index is equals to, I have 1, 2, 3, 4. So I'll just copy this where I have defined. I'll just copy this and I'll say index is equals to this. I'll just erase this part and I'll say comma columns, I guess columns columns is equals to, maybe I'll copy this part and I'll say this. So when you run this, okay, there are 5 rows, right? So I'll have to say E. Now you see, this is the data frame. The indexes are A, B, C, D, and E, and the column names are France, India, Russia, and Japan. All right. So you can change the indexes and columns. Any doubt?
Excuse me, sir. Sir, the value of first row, first column will come on the randomly. This value will come.
We are taking randomly. It may not be random. You can define the series and then bring it in data frame. So why did I do randomly? Because I don't want to write 5 into 4, 20 numbers right now. That is why I have used random module. There's no specific reason of using random numbers here.
Okay, sir. Okay.
I have
Continue.
just used it because it makes it easier to give me 20 numbers directly instead of writing 20 numbers. Is it clear?
Okay. Yes, yes.
All right. So you can have any array. It can be any array. It doesn't matter. All right. Now you see, I'll write a heading first. Selection and indexing. All right. So I'll show you how to select some column or rows in a data frame. So we have seen this actually. If you go earlier and you see, we had this data frame, and when we wrote df and inside bracket, I'm writing the name of the column. Here it is temperature. You can extract or select the column of the data frame. So you can do that over here also. I have a data frame, so I'll store it in say df. So in general, data frames are defined using this variable df. You can use any variable you want, but generally it is defined using this variable df. Very general convention, nothing special. All right. Now you can see df and the column name I'll give here. I'll say India. And you see we have the index, and index is intact. You see your index was this A, B, C, D, E, and index is intact. Index is not changing. And you extracted this column, the values of this column. And if you check what is the type of this type, this thing, you will get series. You see Panda series, it is actually a series. And if you check for df, you will get data frame. Type df, you will get it is a data frame. All right. So this is one way of extracting data or selecting a column. There is one more way, but it is not recommended. So I'll write not recommended. Method is not recommended. It is df dot, and you write the column name. Here it is India. And when you do, then you will extract the column of the data frame. And this is actually the convention used in SQL data, SQL. All right, so they use this convention dot something. But why I am saying it is not recommended here is because we generally use functions when we write dot and give the function name. And sometimes the function name may uh, be same as your column name. Suppose you have some column name, say items, and a data frame may have a function called item. So you can check. You can say df dot, and when you press tab or shift tab, no, shift tab, no, tab, you see these are the functions which you can use for item, sorry, data frame. And when you go, you can have some empty or equals. These are functions. So you see this is a column name France. So it is showing what else you can use. Okay. So suppose you have items. So you see this is a function. This is actually a function, but you may have column name as items. So that way there will be a clash. And this is why this method of extracting a column is not recommended. All right. You can select more than one column in a data frame. How can you do that? You can just, instead of passing just one string, you can pass a list of strings, a list of whatever column name you have. It may be a string or a number, it doesn't matter. But if you give more than one column name, you will get what more than one column name. So what are the columns we have? We have India, France, Russia, and Japan. I'll say Japan. India. You see, we have extracted the column and India and Japan. Now you can actually add new columns to this data frame. All right, so I'll just show you what the data frame is. This is the data frame. You can add new columns to the data frame. You can say df and maybe some name, maybe uh, new. The name of the column which we want is new. All right, and I'm saying df India plus df Japan. So these are two additions. So additions of series. You see, df India is a series. We saw this. df India is a series. df Japan is also a series. And when we add two series, if you go back to the series section, and we talked about adding two series, what happens is it matches the indexes and then adds the value. So here the index are same because we have defined in that way A, B, C, D, E. So what it will do, it will match the index A and add it, B and add it, C and add it. All right. And we are assigning this value. So let me do like this. So I'll just erase this part. If you add this, so this is a series you are getting. Now you can assign this to a new column. And this column new is actually not there in the data frame, but you are assigning it to a new column and it will create a new column in the data frame df. All right. And when you see what df is, you see these values are actually in this column new. You have this value, and you can check it is the same. All right. So this is how you can add new columns to an existing data frame. Any doubt? Similarly, you can drop a column from the existing data frame. Suppose you don't need this column new in your data frame and you want to remove that column from the data frame. So there is a function called drop. And when you specify drop, you have to give the name of the column you want to drop, which is new over here. And so listen very carefully. This is important. All right. So when you say df.drop and you say something, actually drop things that you are wanting to drop a row. All right, it actually uh, it is defined that way. So the what it is called base value, not base value. The default value of this drop is actually dropping a row. And how do we define a row? If you remember, we say axis is equals to 0. So if you don't say axis is equals to 0, it takes as a axis equals to 0. Now, if you try to do this df.drop new, you see you don't have a row named axis, sorry, named new. So you'll get an error. Why are you getting an error? Because drop things, listen this carefully. Why are we getting an error? It is because drop function's default value is of dropping a row, and it is checking if a row is named new or not. It is not. That is why it is giving you an error, and it will say new not found in axis. Why? Because there is no row named as new, but you have to tell that I want to drop the column and not a row. Then you have to say axis axis is equals to 1. When axis is 1, it means you are talking about a column. And when you do this, then you will see the new column is dropped from the data frame. There is one more important thing to tell about. But before that, have you understood this axis equals to 0 and axis equals to 1? I'll show you one axis equals to 0 part also for more clarity. So if you say maybe A, capital A, and you say axis is equals to 0, then it will drop that row. Now, if you don't define the axis and you say drop A, then also it will work. You see, you need not define axis equals to 0 when you are talking about a row. All right, but this is not complete. I want to come back to drop because one important thing is left. Before that, have you understood axis equals to 1 and 0? I hope it is clear. All right. Now, you see, I'll delete. Okay, I'll delete this part for now. So you see, we have dropped the column new. We don't have the column, right? But if you come back and see what df is, you will see the new column is already there. Then what is this drop doing? Drop is actually not changing this data frame df. It is not. It is just giving you one more object with no column named new. So what if you want to actually modify the original data frame, there are two ways to do it. There are two ways to do it. You just take this and assign this to df. Df is equals to this. In this way, you are just replacing the original data frame with this data frame. All right, this is one way. Way one. All right. Another way is, I'll just comment this out. I'm not executing it. Don't execute it because you'll get an error. Why are you getting an error? Um, okay, let me do this. So when you do this, you see you don't have a new column in df. This is one way. Suppose you don't want to use this way. You're saying that why should we assign one drop to another drop? Is there a way that we can modify the data frame itself? Yes, there is a way. Before that, you need to have a column called new. So I'll just copy this and I'll write new equals to this and I'll see if the data frame is, yeah. So you have a new column now. So what is the way? You just take this and there is a function called, not function, sorry, argument called inplace. And you have to say inplace is equals to true. What is this doing? You see, when you did df.drop and you said new, then it was dropping that new column, but it was not changing this df. It was not changing the data frame itself. But if when you say in place is equals to true, it means that you want to change the data frame df. Please don't give me one copy. You actually change that data frame which we are talking about right now. So when you execute this and when you check df, you see df is actually modified. So this is the second way of actually modifying the data frame. Way two. Any doubt? So I guess there will be a doubt about what this in place is. Any doubt? This is important actually. So if you have doubt, you can ask me again. So this in place is equals to true is actually telling Python that I want to actually modify this data frame df. Please don't give me a new object data frame. All right. And we also talked about dropping a row. So I'll say drop. I'll say E when you do this, then it is actually dropping row E. And this is also not changing the data frame. The data frame remains the same. If you want to tell Python that please modify the original data frame, you can do that. First, I'll write access is equals to 0 because you will have this. But if you want to tell Python that no, I want to actually modify the existing data frame, then you have to say this comma in place is equals to true. And when you say this, then Python will understand, okay, I want to modify this data frame. I don't want to get just dropped row and one more object. No, I want to modify the data frame. When you do this, then there is no row E in this data frame. Any doubt? All right, so what have we seen till now? First, we have seen that this pandas library makes it very easy to handle data. You can load data in the memory, you can select data in the memory, you can run operations in that data, you can combine data, you can manipulate data and so on. All right, it is very easy. Otherwise, you will have to do a lot of code is required to do all this. All right, you can do that without data frames, but you'll have to get into very uh, nitty gritties of your code. All right. Then we saw one object called series in pandas, and we saw how do we define series. All right. Then we talked about that series has an index which you can change. All right. We saw dictionaries that you can convert dictionaries into series. You can add series, and we will. There are other operations also you can do. Maybe you can see. You can say series one. Sorry. So you can say series one equal to series two. So it is checking if all the element. So element wise checking will be there. Okay. Can only compare identical labeled series object. Okay, this is because the label is different. That is why you're not able to do this. All right. So you can also do equal to. If the labels are same, you can check if the elements are element wise comparison will be done. All right. Now we have seen data frames, and we talked about, before going to data frames, we talked about the seed. This is not related to data frame, but since it was a important thing to talk about in random module, that's why I came and talked about seed. That we saw how do we define data frames. You can have indexes as well as column names for a data frame. Then you saw how can you select a column in a data frame. So till now we have not seen how to select a row. We have only seen how to select a column in a data frame. Then we saw you can select multiple columns in a data frame. You can add new columns to a data frame using this way. All right. Then we saw you can drop columns or rows in a data frame. Okay. You can drop in place is equals to true and in place is equals to false. The default value of in place is false. That is why df was not changing. Whenever you say in place is equals to true, the default value of in place is replaced by true and df is modified. All right. Then we saw how do we drop a row, and then we saw that you can also write in place is equals to true and modify the original data frame. All right. Now we will see how to select a row. Till now we have not seen how to select a row. We have only seen how to select a column. Now we'll see how to select a row. All right. So selecting rows, there are two ways to select a row. So I'll just write like this and I'll say ways of selecting a row. All right. So there are two ways. There is iloc and loc. So we'll see what iloc and loc is. First, let me see. I have something or not. So df, what is df? Yeah, it will work. Right. So this is what df is, and we want to select a row. All right. Now you see this loc. When you use loc, so how will we use loc? We'll come to it. So when you use loc, you have to specify the name of the index. So this the name of the index is A. The name of this index is B. This row's index. The name of this row's index is C. So whenever you use LOC location, you have to give the name of the index. Similar to dictionaries. If you want to give the extract some value of a dictionary, you have to specify the key. All right. But if you use iLocation, it is actually saying that you give the index position of that location. So similar to list. In a list, you have to say list name and give the number, index number 0, 1, 2, 3, 4. It doesn't matter what the value is. If you give the location number, then you can extract it. So I'm just talking, show you. So how you have to extract the row, you have to say df dot, and when you say loc location, you have to give the name of the index. So I'm saying B. When you do this, then you see this is B and you're extracting this row, not everything, this just this row. All right. So saying France value is this, India value is this, Russia value is this, and Japan value is this. This is how location works. But if you say I location, df dot I location, then you don't have to give the name of the index. You have to give the number of the index. So B, this row is actually this first, not first row, at position 1. So this row is at position 0. This row is at position 1. So you have to say I location 1. When you do that, then you will be able to extract that row and you will see the name it is saying B and data type is actually float. Doesn't matter. But you see you have extracted this row using location and I location. Any doubt?
No, sir.
If you want to extract this particular element, B in India, so what you have to say, you can say df dot loc and you say B, comma, India. When you do this, you will be able to extract this value 0.915, this value. All right. So you're getting extra because it is not showing here. The more decimal places are there, but that value you have extracted. I guess you can do that using iLocation as well. iLocation and B is in location 1 and India is also in location 1. You see, you can extract that value this way. Now, what if you want to extract more than one element? You want to extract A, B, and France and India. So you want to extract this submatrix from the whole matrix. So this is not a matrix, but you want to extract this small data frame from the whole data frame. You can do that. You just have to pass list. So you have to say df dot lock and give the list. You say first you have to give the row number. So it will be A, and then you have to write B. And over here you have to write France, and then you have to say India. And when you do this, you will be able to extract this sub data frame from the big data frame. And I guess you can do that using iLocation as well. So you can say 1 0 comma 1 comma 0 comma 1. Yes, you can do that. You can use negative values also. So this will be -4, I guess. Yes. So you know na, that negative index is also there. So negative index can also be used. We have talked about negative index a lot. If you don't remember, you can go back and see what negative index is. All right. Now we'll move on to conditional selection, and which is very, very important part in um, data frames. What is conditional selection? Suppose we have done this actually, conditional selection. If you go back, you see, we told that whenever this event is rain, whenever the event is rain, then give me some part of the column or some part of the data frame. So that is what we did. You will not be able to understand this right away. We will talk about it, but this is what we are doing. Conditionally selecting some part of the data frame. What is the condition? The condition is whenever this event is rain, whenever this event is rain, give me that the value of est. That is what we did. This is what it is. Whenever the event is rain, give me the value of est. This is called conditional selection. All right, and we'll see how to do that. So I'll write conditional selection. Okay, and yeah, we will move into this, but after a break. So we'll meet at 12:05. 12:05.
Ayyo.
Yes, so I'm late 1 minute. All right. So we're talking about conditional selection, right? 1 minute. Okay. So we have a data frame called DF, and we'll see what it is. So this is the data frame. So you can, so remember when we were talking about NumPy arrays, you can check if, so whenever you say that NumPy array is greater than 0, you had a array with Boolean values, either true or false. You can do that here also. So if you say df greater than 0, you will get Boolean data frame. So the values are either false or true. All right, you can check. So I'll just copy this and you can say type. And when you do this, sorry, df greater than 0, not type, sorry. Mm, Okay, you can do that using series. Can you get d type maybe? I don't know if this will work, but let me check. Tf1 is equals to tf greater than 0, and I'll say tf1 dot d type. Data frame object has no attribute d type. I'll see. But yeah, this is a Boolean data frame. All right, the values are Boolean. Now, what you can do is, you see, this is a condition which is saying if df is greater than 0 or not. This condition you can pass as a uh, so whenever we are saying df bracket, you can give a condition also. So you can do conditional selection. What does this mean? Whenever there is true, it will have that value. All right. So you see, I'll say df greater than 0. And when you do that, you will get wherever there is true, you will get the value, and wherever there is false, you will get not a number. All right. But generally, we don't do this. All right. We don't do all data frame greater than equals to 0. Why don't we do that? If you go back over here, you see in a data frame, you can have different kinds of values. You can have dates, you can have temperatures, you can have dew point, you can have name, marital status, and so on and so forth, addresses, card numbers, amount paid at a restaurant, and so on. So you generally don't do the entire data frame greater than a value or some condition on the entire data frame. You do these conditions on a column. All right. So generally this is not done. So I'll write generally 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 this is not done. So what do? We actually do conditions on one column, generally a column, not a row also, because you see over here, rows are actually uh, what you say when you take um, so when you run an experiment, you take values or I am not getting the term. If anybody can tell me, instances, or yeah, I don't remember the term. So these are values of these categories. All right. So generally the condition is given on this, because in a row the values can have different data types. One can be an integer, other can be a float, other can be a string, and so on. All right. So conditions are generally given in a row. So we'll say df and we'll give a name. So I'll say India. So what is this? Okay, this is a string, so you have to give it inside. So this is my row, and in this you will give a condition. So you'll say greater than equals to 0. Then you will actually get a series with either true or false, and you see the d type is actually Boolean. This is what I was trying to get. All right, so the data type of this series is Boolean, and in this condition you have given on a row. Now what you want, you are saying that whenever India's this value is greater than equals to 0, then get me the data frame. So you're saying df inside box bracket, you give this condition. So you're saying for this condition, give me the entire data frame, but this condition should hold in the entire data frame. And when you do this, then you see the data frame you're getting, and the values you are getting for the data frame is only for when India's value is greater than 0. So you can also over here, I'll say df1, and we can use this for more examples. All right, so I'll say this and we have a data frame called df1. You see, this is the data frame, and I'll say for df1 temperature, I'll just copy this, and you should copy this back actually. If you don't do it, then you can have issues with uh, spelling. So spelling error shouldn't be there. So I'm saying whenever the temperature is greater than 30, and these temperatures are not in these temperatures are in, I guess, Celsius. No, 50 degrees Celsius. I guess these are not Celsius. These are in Fahrenheit. It doesn't matter. These are just values for us now. So we have a series, and you can say whenever the temperature is greater than 30, get me the data frame. So you will say df1 and pass the data and condition inside this indexing, and you will get only those values where temperature are greater than 30. I guess all temperatures are greater than, just a minute. No, 12 is less than 26. Okay, you are not getting some values. You see, 12 is not there, 13 is not there, 21, 22, 23 is not there, and so on. Yeah, so you're getting a data frame where temperature is actually greater than 30. All right, so this is how conditional indexing is done. Any questions in conditional indexing? Now you can also change the index. So yeah, any questions in conditional indexing? There can be multiple conditions. All right, so suppose what you want. So let me show one more condition. Suppose you see, this is one condition you have given, that temperature is greater than 30. You can have more conditions also. You can say whenever humidity is also greater than 50. So this and this. So what if you want this and humidity greater than 50 maybe? So you say this, and over here I will write, and I have not written it because there is something I have to tell you, but you have to say humidity. Humidity is greater than 50. Humidity is greater than 50. And over here, you will not write A and D and. You will have to write bitwise and. Why? Bitwise and because you are checking individual elements of the row. So you're doing element wise and. What do I mean by that? You see, I'll tell you df1, and this should be there. Yeah. I'll show you what it means. All right, first let me see. Hmm, what error I made here. The truth value of a series is ambiguous. Use a. Just let me see what error I made. This is okay. This is also okay. Yes, I'm doing it correctly. What is this?
So one square bracket last.
I guess, no, sorry, what error I made? I guess this should be in bracket, I guess. I'll just, let me see. Yeah, what are
The
you saying?
parenthesis last bracket after
Okay,
50.
okay, yeah. Okay, yes, 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 yes. Thank you so much. This will not be here, this will be here. Yeah. Thank you so much. So when you, no, it was correct, I guess. What? No, I was correct. Let me see this. Yeah, okay, now it is working. So this is one series and this is one series. Okay. So the you need a parenthesis for this. So what it is saying is, you do this, you get the series, you do this, you get the series, and then you do bitwise and. So what is bitwise and? You do element wise and. So when you do this, you have something like this. So some are true, some are false. You do this also, you will get a boolean series. Over here, you will get a boolean series. And then you do bitwise and. So first you check true. So zero will come. You see, zero is there. Then this is true and this is false. Then one will not come. So that is why you have to do bitwise and. This is actually bitwise and we have talked about operators. When we were talking about operators, we have talked about what bitwise and is. All right. So this is how you can do conditional indexing with more than one condition. You can also do or operation. So I'll just copy this and you can do or operation. So or is actually this sign just below, just above enter sign. This is or operation. All right. And when you do this, then it is or either this or this. So this is another condition. There are some other functions also. You can do df1 dot head. So when you do this, then you will get the first 5 rows of your data. So suppose your data are 22,000 or uh, thousands of rows are there in your data. So if you do that, a lot of things will be printed in your screen, but you don't want to do, you just want to have a glance of what your data is, what are the columns. So you can do df1 dot head. Similarly, there is something called tail. So you get the last 5 columns of your rows of your data. You can pass some values in this. So when you say df1 dot head, you can say 10. So you'll just get the first 10 rows of your data. Similarly, in your tail, if you give some value, you are saying df1 tail and say 10, you'll get last 10 values. All right. So these are some ways of seeing your data. All right. Then there are other functions also. You can do df1 dot describe. So when you do df1 dot describe, you will actually, so this describe actually works for numerical data. So if you have strings in your data, then those columns will be dropped. All right. What it is doing, you see, it is taking the columns which are not strings, which are actually integer or floats. So you see this est is neither integer not float, so it is not here in this list. It is only taking integer or floats. This event is also not taken. Now what it is doing is it is giving you the count, it is giving you the mean. So mean of all the temperature values, mean of all the dew points, mean of all the humidities. So this is the mean of temperature. This is the mean of humidity. So these values are given. So mean, standard deviation, minimum, maximum. This is 25th quartile, 50th quartile, and 75 quartile. Alright, so this is some ways. Now there are other functions also. You can do df1 dot value count. Value or values. I guess value count. No, value counts. I don't remember exactly. Yes. No, this is not I want. Uh, Let me. I forgot value count function for data frame. Value counts, right? Mm, okay, I don't remember these functions. Uh, there is something called unique. So you can say df. Why am I not getting this? Pratibha, I guess you are familiar with data frame. Can you help me? I guess value counts work with
Yes,
series, I
yes.
guess. Value count works with series, I guess. Series one dot value counts. Yes, it works with series. Yes, that is why. So you see what I was doing wrong. I'll show you. You see, we have a series here, temperature. No, not temperature. Let me do events. EVENTS. Yes. So this is a series. Over here, you can do value counts. So you will say value, VALUE counts. And when you do this, then it will give you the count of the values. So rain occurs 4 times, snow occurs 3 times, and fog occurs 2 times. So this is a function in series, value counts. Similarly, there is something called n unique, df1 dot nunique. It will give you the unique values in df1. In series also you can get. So in series, if you get, so you can see there are three unique values which are rain, snow, and fog. So rain has, so this event column has rain, snow, and fog, three unique values. If you do this n unique in data frames, NUNIQUE, then you will get how many unique values are there for each column. So EST has 31 unique values, temperature has 22 unique values, and so on. This events has three unique values, and so on. All right. Now there are other functions also. Um, there is something called unique as also unique. Uh, no, you can also get columns. So if you say df1.columns, you'll get the columns. Yes, you'll get the columns. So these are the columns. So suppose your data has a lot of columns, maybe 40, 50 columns, then it will not be possible for Python to show all the columns to you. But you want to know what are the columns, then you can do like this, df1.columns. So you'll get all the columns you have for a data frame. All right, and there are other functions also in data frame. I am just remembering these things, so I'm telling you. All right, now I wanted to tell you about, um, let me go to maybe multi-index. Yeah. So before that, uh, these operations which we are doing in data frames, is it clear? And why do we need this? How it is important? How it is helping us? Maybe all this. All right. So I will load one data. So I'll say df is equals to pd.read CSV. I have one more CSV file in memory, which is named as weather data, WEATHER. Data cities, CITIES dot CSV. And you can see what df is. So this is my data frame. It is a small data frame which only 12 values, and you have cities New York, Mumbai, and Paris. All right. So you see there are four values for New York, four values for Mumbai, and four values for Paris. You have temperature, wind speed, and event. Event is either rain, sunny, snow, fog, and cloudy. You can check easily. You can say df1 df dot, not df dot. You can say df event ev and event, and you can say dot um n unique, not n unique value counts. You can see you have four sunny, three cloudy, two rain, two fog, and one snow. So you can just check your data. If your data is very large, these functions are very useful. But we are not talking about that. We are talking about group by, and it is a very important function. And if you have used Excel, you have uh, used, I guess, pivot table. So what pivot table does, it is very similar to what group by will do here. All right, group by is actually capital B, group by. Yeah. Now you see what I want over here in this data frame. This New Yorks are occurring in same, consecutive rows. Mumbai is occurring in consecutive rows. Paris is occurring in consecutive rows. It may not be the case. You may have shuffled values also. But what I want is I want to group all the values in this data frame which has Paris in the city. So the city is Paris also for Mumbai and also for New York. So I want to group those data and then club it together. And whenever I want to do something, suppose I want to get the average maximum temperature. So I want to get the maximum temperature in New York, maximum temperature in Mumbai, and maximum temperature in Paris. So in these three groups, I want to get the maximum temperature. So in that case, group by comes. Otherwise, if you do maximum temperature, it will do the maximum temperature for all the rows you have. But you don't want to do that. You want to take a group and then do some operation. Suppose you want to group all Paris data and you want to check what is the average wind speed. You want to group Mumbai data and you want to say what is the average wind speed and so on. That is why you need group by. All right. So you can see G equals to df dot group by and give the column name which is city. All right. And you can do this. Okay. Group group by. And when you see what G is, it will give you an object group by object. All right. It is actually a group by object in Python. How can you see what this group by object is? You can actually iterate inside this object. I'll show you, but this is not how group by is used. I'll show you how group by is used, but for the time being, I want to show you how this group by is storing data in memory. So I'll say for city, comma, city df in G, print the city name, city. Okay, not sorry, city, yeah, city name, which is city, and then print the city data frame. So I'll say city df, and then I'll say print such that I get one space. All right. So you see what it is giving. It is taking Mumbai as the city, and this is the data frame it has for Mumbai. This much. It is taking New York as the city, and this is the data frame it has for New York. Similarly, it is taking Paris as the city, and this is the data frame it has for Paris. All right. So it is just grouping data. It is grouping for Paris, it is grouping for Mumbai, it is grouping for New York. Why? Because you have passed city. In place of city, if you have passed something else, maybe events, then it will group by events. It will group sunny, it will group fog, it will group cloudy, and so on. All right. So whatever you want, you can group those data together. Now you can perform operations. Maybe you can say g dot get group and you pass some name, maybe New York, what it is, NEW space YORK, and you will get the data frame for New York. Similarly, you can get the data frame for Paris, PARIS. You can get the data frame for Paris. You can perform operations. You can say G dot max, and when you do G dot max, you will get separate data. So you see, for Mumbai, what is the maximum temperature it will give you? What is the maximum wind speed it will give you? And sunny doesn't matter. Actually, it is checking the maximum of strings. So if you remember, you can compare strings. So A can be greater than, so B is greater than A. So that alphabetical order it maintains. So it doesn't matter. You don't require this, but you can get grouped maximum. So 92 is maximum temperature for Mumbai. If you go back and see, this is Mumbai data and you see maximum is 90. No, 90, 92. So this is the maximum. For wind speed, it is saying 15. You can go back and see this is maximum. All right. For New York also you got, you Paris also you got. You can take mean also. You can say g dot mean and you will get mean data for the groups. You can also do describe. So over here we did describe. We did it in the entire data frame. All right. We did it in entire data frame. But you can do describe for uh, groups. All right. When you see g dot describe, you will get groups. You see, for Mumbai, you will get all the data you have. So this is actually temperature. For temperature, the count is 4. Min is this, standard deviation, minimum 25, fifth quartile, 50th quartile, 75th quartile, and maximum. For wind speed, the count is 4. Mean is this, standard deviation, minimum 25th quartile, 50th quartile, 75th quartile, and maximum. So these are grouped description. And it will be easy if you write print to see what it is doing. If you say print, then it will understand better. So you see this is temperature description and this is wind script description. Right. Any questions? So this group by is a very important function in data frame. Lastly, this is the last thing we will talk about. We'll talk about concatenation. Right. So we'll talk about concatenation. So if you have multiple data frames, how can you merge those data frame? How can you concatenate those data frames? All right. So we'll talk about merging and concatenation. Okay. Are you able to understand what I'm explaining, or is it becoming difficult?
No, sir, it's okay, sir.
Understanding.
Okay. So I'll go over here. We have some data frame. Hmm, this is one data frame we have. So I'll say df1, not df1, df2. This is df2. So this is what we have. And one more we had. Just 1 minute. I'm copying some data such that I don't have to describe, write it again. This is France, India, Russia, Japan. All right, I'll write one more time. So this is what df2 is, and I'll say df1 is this, and I'll change few things. All right, what will I change? I'll say I'll remove index maybe. Let me remove index for now. Right. So columns we have, and the columns are France, India, Russia, Japan, and maybe I'll change here China, and I'll change this to USA. Yes, this will work. I'll set it to TF3. You see, we have some data, and in this uh, the concatenation, I should write it in index only. No, let me write the data frame. Don't want this type of data frame. I'm sorry, huh? I'll just write the data frame quickly. So I'll write pd dot data frame, and I'll pass a dictionary maybe. Yes. Then I'll say city, and the city name is, I'll copy from here. These are the city names. So I'll write the city names. Then I'll write temperature. So temp, and I'll give some values, maybe 30, 20, 40, 37. Is 4 values, and maybe one more, say humidity. And I'll just say 80, 70, 60, 50. Okay, this is my data frame 2. So I'll say df2 will see this. Okay, there should be comma. This is my data frame, and I'll copy this. I'll write one more data frame with some other cities. So maybe this is the Russia. I have Japan, and this is France. Okay, so this is my data. So you see, we have some data, and in this city, two are same and two are different. All right, and now I want to concatenate this data frame. So you can use a function called concatenate. So you can say pd dot concat, and you can give the name of the data frames. So say you're saying df1 comma df2, and when you do that, okay, not df1 and df2, you df2 and df3. So when you do that, you see this is what it is doing. So, eh, this is the error. This is df3. Yes, yes. Sorry. This is df2 and this is df3. No, yeah, this is what we wanted. I'm sorry for the confusion. I'll just start again. All right. So we are talking about merge and concatenation. What I have done is I have defined a data frame df2, and this is my df2, which has three columns: cities, temperature, and humidity. And these are the values. Similarly, I have defined df3, which have cities, temperature, and humidity. And there are cities: Japan, India, Russia, and France. You see, some of the cities are same. So these are not cities, actually countries, but I have written cities. So let it be. So some cities are same and some cities are not same. Now what I am doing is I'm concatenating. When I'm concatenating, you see it is not checking if India we have same or Russia we have same. It is just keeping one data frame and then the other data frame below it and just giving you another data frame. All right. Now we will see how we can solve that. But you see one more thing. The index is 0, 1, 2, 3, and here the index is 0, 1, 2, 3. What if you want to reset the index to 0, 1, 2, 3, 4, 5, 6, 7, 8? What if you want to do that? You can do that by saying ignore index. All right. So we'll come to that how we can merge India and Russia. But before that, let me show you how you can change the index. So you can say ignore index equals to true. When you do this, then a new index will be given 0, 1, 2, 3, 4, 5, 6, 7. All right. So the old index will be ignored. Now you see over here, it is added one on top of the other or one below the other. What if you want to add one in columns? So the first will come and then beside that one more will come. You can do that using axis is equals to 1. So over here it is actually concatenating at axis is equals to 0. When you say axis is equal to 1, it will add column wise. Right? When you say axis is equals to 1, it is actually adding column wise. Mm. Yes, axis is equals to 1, it is adding column wise. All right, you see city, temperature, humidity, and city, temperature, humidity. It is adding column wise. Now you may ask me, why do we want to do this? We want to merge the things. You want to merge India in India, Russia in Russia. You want to do that, then you can do that. But for that, you should have these columns as different because this will conflict. You see, this is also temperature. This is also temperature. If India and India value merges, what will these values be? So suppose the value of this is not temperature, it is something else, and then you want to merge. You have two data in your memory, and this data frame has the values of temperature and humidity, and this values has population and something else. And then you want to merge the two data frame. Then you usually don't use concatenation. You use the function called merge. And for that, I have to change this data frame. Suppose this is not temperature, this is wind speed, and maybe this is not humidity, something else. And somebody give me some rudimentary example of what can this be. Sunlight, sun density or sunlight density. All right. So I have changed data frame 3, df3. Now you see, now if you want to merge to data frame, you can do that. You can say df dot not df, you can say pd.merge, and then you can pass to data frames. What are the data frames? df2 comma df3. Moreover, you have to say on which column you want to merge. Therefore, you have to say on, and then you have to say city. So you want to merge on city. And when you do that, you see India and Russia is common. That is why you only get two rows and everything is merged. You see temperature is there, humidity is there, wind speed is there, and sunlight density is there. All right. So concatenation is it is just combining the two data frames. It is not checking we should how are we doing the data frames together. But merging, it will check which value matches with which value, and then it will write over. Now you may say we have lost some data. China is lost, USA is lost. Similarly, Japan is lost and France. What if we don't want to lost it? So you see, you can keep those using something called how. So what is how? You see, when we merge some data frame, so this is actually inner merging. What does inner merging say? It says only keep those data which are same, or the value of the merging thing is same. But if you say outer join is something else, it says keep everything. All right. So when you say how is equals to outer, so what it will do is it will keep everything, and wherever it doesn't find a data, it will say nan, not a number. So over here, it is actually inherently saying how is equals to inner. When you say this and you say how, you will say inner. So you see this is and this is same. It is inner join. This is actually known as inner join, and this is actually known as outer join. All right. And why I am using the term join and not merge? Because join is a technical term used in SQL. Merge is used in Python. All right. Both the things merge and join are same. All right. So this is how you can merge to data frame. You can do outer join or inner join. When you are doing inner join, only common values remain. When you're out doing outer join, non-common values are also there in your data frame. Moreover, you're not modifying the data frame. So you have df2 and df3 intact. You are actually creating new data frame. So df2 and df3 are there. This is a new data frame, and you can store it into something called df4. Right. So you're storing it in some data frame. Right. This is it I wanted to discuss about in data frames. There are a lot of things left in data frames. If you go in depth, then it will take a lot of time. Maybe one whole course can be there in NumPy, Pandas, Seaborn, and maybe other. Yeah. So I've just given you very basic understanding of these. And one thing I want to tell you, so you see, you have one index, you can have multiple index. So similar, so if you go to a, suppose this is a table, so data frame is similar to table, you can have merging. So you can have this as one index and you can have some sub index. So suppose this is one index, how to merge, this is merge. And in this you have some sub index. So this is sub index and this is sub index. Okay, so this is the topmost index, hierarchical index. This is the sub index. You can do that. Something called multi index is there. It is similar to group by, but in group by you are not defining it as an index. All right. So yeah, I have left a lot of part of pandas because I just had one class and it will take a lot of time to discuss everything. So this was just an introduction to pandas. So Pratibha, you are aware of this pandas and NumPy, I guess. So yeah, how was
Yes,
the discussion? Was it fruitful or uh, not so good?
sir, it was fruitful, sir.
All right. So you are aware of Python language, right?
Sir, actually, I started learning Python only after attending the class, sir.
Okay, so how did you learn pandas and NumPy libraries then?
Sir, actually, my husband helped me.
Okay, okay.
Actually, he's into computers, so
All right.
yeah.
Okay, yeah. So that was all for this course. This is the last class, and we'll not meet again maybe. Uh, but yeah, you can reach out to me anytime you want. And yeah, one confession I wanted to make since the first class, I learned Python on August of this year. So I was not aware of Python before that. So I am also learning along with you. So I hope I did justice to this course. Yeah, I was learning along with you. So I had done Python in the time of August, September, and October. After that, I started this course on September. So I hope I did justice to whatever I have taught.
Yes.
So I'll just take the attendance. Just 1 minute. Ram Prakash is here. Danis is here. And Pratibha is here. All right. So thank you for joining. If you have any doubt, you can ask me. And regarding certificates, we will have a lot of discussions in the group in subsequent time. So I will not contact ISS team before 13th. After 13th, and when Danish submits, so I'm thinking to contact them after 16th because I have asked Danish to submit the project by 16th. So after that, I will give the details to ISIS team. All right. So maybe you have to wait uh, a little bit of time to receive the certificate.
Okay, thank you, sir.
All right.
Sir,
Thank
I
you.
need to know, excuse me, sir. Sir, what
Yes.
is the ISS login and password, sir?
Actually, you have joined late and they have may not have created your login ID and password. So that is why you will not be able to join the course platform there.
So how I can, sir, get?
So I have actually uploaded everything in that drive. So is there any other requirement you have for that platform?
Okay, okay, I can get from the lecture series.
Yes, in the drive, everything is uploaded.
Okay, thank you, sir.
All right. Yeah, so I'll end the recording now and meeting also. Thank you for your time.
Thank you, sir.
Thank you, sir.